Hello everyone. In this video we will finish up our examination of topic 9.4 resolution by examining the resolvance of diffraction gratings. So diffraction gratings, as we've seen in a prior unit, you may want to pause here and remind yourself of all that we know about diffraction gratings before moving onwards. But diffraction gratings can be used to resolve the intensity of particular wavelengths of light by spreading out that light into a spectrum. In other words, they help us see what wavelengths of light are in a source. If you send white light into a diffraction grating, it'll spread that light out into a rainbow, so you can see the different colors of the light. But they're also used to spread out sources that don't have the same amount of light at every wavelength. To take a complex source of light and split it into the wavelengths of which it is composed. And if you're doing that, you want to be sure that you can measure the difference between different wavelengths. So for example, in this little graph over here, imagine that your source of light only had red light and blue light in it. Well, you would want to make sure that when you sent it through the diffraction grating, that the separation, the angular separation that the diffraction grating guarantees you, is enough to tell the difference between the red light and the blue light. In this diagram, they're clearly far enough apart, but it's not at all obvious that red light and orange light, for example, would be far enough apart to resolve, to tell the difference between them. So, in order to do this, we define a quantity called the resolvance, R. And this is just a fixed quantity. I'm not going to prove it. I'm not going to derive this equation. This is just one of those plug and chug kind of equations. But it does make sense, and it is a useful quantity. And it's calculated by taking the average wavelength between the two wavelengths you wish to resolve, and dividing by the difference between them. So delta lambda is the difference between the two wavelengths, and then lambda average is roughly where those wavelengths are. So this recognizes the fact that delta lambda, the difference between those two wavelengths, is not quite sufficient to characterize whether you can resolve things. Why? Because it's harder to resolve higher wavelength light. Because higher wavelength light diffracts more, you need a larger delta lambda to achieve the same resolvance. There needs to be a larger difference between the two wavelengths you wish to resolve at higher wavelengths than there is at smaller wavelengths, because the smaller wavelength peaks are going to be sort of closer or tighter together. So what that means is that we can then take this quantity resolvance. That's our quantity that says how good our diffraction grating is. A high resolvance diffraction grating is a very good diffraction grating, and it separates light very well. And we can say empirically that that resolvance R is equal to m times n, where m is the order of the diffraction. Okay, so you get higher resolvance at higher orders because that light is being spread out at greater angles, times n, the number of lines actually illuminated. And at higher order, the angle is bigger, so that gives you better resolvance, and with more lines, you get a spikier effect. Remember when we compared the double slit effect to multi-slits and multi-slits to diffraction gratings, you want very high spikes in your diffraction grating peaks, because those spikes, you'll have one for red and then also one for blue. And it's the spikes that you need to be able to tell apart. The spikes are what gives you the different wavelengths in your light. So the spikier they are, the higher the resolvance. A low resolvance diffraction grating will look kind of whitish in the middle as that light sort of lies on top of each other. The colors will not be as clear, whereas with a high resolvance diffraction grating, those colors will be easy to tell apart. And this equation can be derived, but in the IB, you just need to be able to plug and chug with this particular guy and to understand sort of what the resolvance is for, so what it means and how it characterizes the diffraction grating.